All right, let's jump right in. For literally thousands of years, we've looked up at rainbows, we've painted with colors, we live in this incredibly vibrant world, but it was just over 300 years ago that Isaac Newton decided to really tackle one of the most basic, fundamental questions hiding right in front of us.
I mean, it sounds so simple, right? But this question, it had the greatest minds completely stumped for centuries. Is color something inside an object? Is it, I don't know, something that happens when light and darkness mix? Or is it something else entirely?
Well, the answer was going to be laid out piece by piece in his incredible book, Opticks. And in it, he made his mission crystal clear. He said, "My design in this book is not to explain the properties of light by hypotheses, but to prove them by reason and experiments." He wasn't just going to guess, he was going to prove it.
Now, to really get how big of a deal Newton's work was, you first have to understand what everyone thought they knew about light before he came along. So the running theory was that white sunlight was the purest, most basic form of light you could get. And colors, the kind you see in a stained glass window or when light hits a prism, they were thought to be created when that pure light got, well, modified, tainted, or stained by whatever it passed through. But Newton, he wasn't satisfied just accepting that. He wanted to put it to the test.
And this brings us to Newton's legendary prism experiment. It all started back in the 1660s with a really simple setup designed to find that first solid clue.
Okay, so picture this. Newton goes into what he called a very dark chamber, pokes a tiny little hole in a window shutter to let in a single beam of sunlight, and then he places a glass prism in its path. Now, what's really fascinating is what he thought was going to happen. Based on everything they knew about how light bends, he was expecting to see just a simple circular spot of white light on the wall, just, shifted over a bit.
But that is not what he saw, not even close. Instead of a circle, the wall was painted with this vivid, stretched-out band of colors, a spectrum, with red at one end and violet at the other. This was it. This was the very first sign that the old theory was in big trouble.
And this observation immediately created a huge question. Sure, the laws of refraction could explain why the light beam bent, but they couldn't explain why it fanned out into this long shape. Why wasn't it a circle? And, as Newton carefully measured, why was it 5 times longer than it was wide? So just as a quick refresher, everyone back then understood the basics of refraction. It's just the bending of light as it goes from one material to another. It's the whole reason a straw in a glass of water looks like it's broken at the surface. But to crack this puzzle, Newton had to come up with a totally new concept, a word he called refrangibility. He basically defined it as the built-in tendency of a light ray to be bent. So what if some rays of light were just naturally more bendable than others? So, like any good detective, Newton knew he had to eliminate every other possible explanation before he could propose something so radical. Was something wrong with his setup? He started to systematically check everything.
He wondered. Maybe the glass in the prism was flawed. So he got another one, a clearer glass and better polish. Nope, same result. Okay, maybe it was the angle of the prism. He tried turning it every which way, making the light pass through thicker and thinner parts of the glass. Still nothing. He even tried using a second prism to see if it would stretch the colors out even more. It didn't. The mystery was only getting deeper.
And here's the crucial realization he had after all that testing. The cause wasn't external. It wasn't the prism, it wasn't the hole in the wall, it wasn't the angle. The reason for the colors had to be something inside, a property of the sunlight itself. This thinking led him to design what he famously called the experimentum crucis, the crucial experiment. And this wasn't just another observation. This was a showdown, a test designed to deliver a final knockout verdict between the old theory and his wild new idea. This setup was just brilliant. First, he used one prism to create that rainbow smear, just like before. But then, he put up a board with a tiny little hole in it so he could block all the colors except for one. Let's say he isolated just the red light. And finally, he would pass that single, pure red ray through a second prism to see what would happen. And you can see here, this brilliantly gets to the core of the question. See, if the old theory was right, that the prism adds color by staining the light, then that second prism should mess with the red light even more, right? Maybe change its color or split it up again. But that is not what happened. The red ray bent again when it went through the second prism, sure, but it stayed perfectly red.
It didn't split, it didn't stretch, it didn't change color at all. It was, as he put it, immutable. And when he tried the same thing with blue light, same story. It bent even more than the red did, but it stayed perfectly blue. This was the smoking gun.
From this one elegant proof, Newton could draw a conclusion that would completely flip centuries of thinking about light and color on its head. He had, effectively, unwoven the rainbow.
The whole paradigm shifted. White light wasn't simple and pure. Turns out it's incredibly complex. It's a compound mixture of all the colors of the spectrum traveling together. The colors themselves, those were the fundamental, pure things. A prism doesn't create colors, it's just a sorting machine.
And Newton summed up his entire groundbreaking theory in this one powerful sentence. Sunlight is just made up of different kinds of rays, and each kind has its own built-in, unchangeable amount of bendiness. Violet light just bends more than red light does. That's the whole secret.
Newton even visualized it for us here. He finally understood that the white light we see is just what our brain perceives when all these different colored rays are hitting our eye at the same time. A prism doesn't make the colors, it just fans them out so we can see the hidden reality that was there all along. And this wasn't just some abstract theory either. It solved a huge practical problem. For years, astronomers were frustrated that the images in their telescopes were always a little blurry with these annoying colored edges. They always blamed it on tiny flaws in the glass lenses. But Newton proved the real problem wasn't the lens, it was the light itself. A simple lens acts just like a prism, bending violet light to a slightly different focal point than red light, which made getting a perfectly sharp image literally impossible.
So just think about that. By carefully observing, questioning everything, and experimenting with a simple piece of glass, Newton completely changed how we perceive reality. It really makes you wonder, doesn't it? What seemingly simple tools are we using today, and what hidden truths about our universe are they just on the verge of revealing to us?